Digital Signal Processing online lecture series. Myself Rima Navar from LG Institute of Engineering and Technology. In today's session, we are going to see some basic examples of the unit Z transform and its applications to linear LTI systems. Welcome to Digital Signal Processing online lecture series. Myself Rima Navar from LG Institute of Engineering and Technology. In today's session, we are going to see some examples of Z transform from the unit Z transform and its applications to application of or analysis of what is this? Welcome to Digital Signal Processing online lecture series. Myself Rima Naval from LG Institute of Engineering and Technology. In today's session, we are going to see some of the examples of Z transform from the unit Z transform and its application to analysis of LTI systems. So, let's start with the first example. Let us consider the data first. So here it is asked to find the Z transform of the sequence given as x of n, that is equals to 2 raised to n u of n plus 3 raised to n u of n. So this is the question of finding Z transform, and it is also mentioned over here, also find its ROC. Okay, so let us see how we can solve this example. So first of all, to find the Z transform of the given sequence, you need to identify that which standard formula or which property can be applied to the given example. So as you can see over here, the linearity property can be applied because this is the terms of a1 x1 of n plus a2 x2 of n, which we have seen in the previous session according to the linearity property. So what we will do is we will find the Z transform of this by adding this 2. So we can say that over here the Z transform x of z will be equals to Z transform of this plus Z transform of the second term, right? Now here we can apply the formula of standard signal, which is a raised to n u of n, for which the Z transform was z upon z minus a, right? So according to this, we can say over here x of z will be z upon z minus 2. Why 2? Because over here the value of a is 2 plus the second term, that means this term, according to that it will be z upon z minus second constant, that is 3. So the Z transform will be x of z, that is equals to z upon z minus 2 plus z upon z minus 3, right? And now remember the table in which we have seen the ROC. So over here the ROC is mod z greater than a. So over here the first value of a is 2. So it is mod z greater than 2 and mod z greater than the second constant value, that is 3. Okay. So if we want to plot the ROC for this, it will be something like this. This is the real part of z. This indicates the imaginary part of z. And this indicates the z plane. This is z plane. Now we have to draw two circles with radius 2 and 3 respectively. So this is the circle having radius 2 and this is the circle having radius 3. Okay. And from this you can say this ROC is entire z plane except z greater than 2 and z greater than 3, or else z equals to 2 and z equals to 3. That means the ROC is mod z greater than 2 and 3. That means ultimately it will be greater than 3. So this is the ROC of the given example. This shaded region indicates the ROC. Okay, so this is how you can find the Z transform and its ROC. Now let us see the next example. So the next example is you are asked to find Z transform of given data as 3 raised to n u of n minus 2 raised to n u of n. Okay. So for this it can be said that over here also we can apply the linearity property. So directly we can find the Z transform. So over here x of z, that will be equals to Z transform of this minus Z transform of this, right? So according to this we have the formula a raised to n u of n whose Z transform was z upon z minus a with ROC mod z greater than a, right? So according to this we are going to have the final answer z upon z minus a. Over here the value of a is 3, z upon z minus 3 minus next is z upon z minus a, and over here the value of a is 2, right? So this is how we can find the Z transform, which is very similar to the previous one except the sign minus over here. Okay. So we can say over here we have used the linearity property, right? Alright. So now let's see the next example. So the example is find the Z transform. Find the Z transform and ROC if you have given x of n that is equals to 1 by 3 raised to n for the interval n greater than 0, and that is equals to 0.5 raised to n with the instant n less than 0, right? So over here indirectly you are given the values of the range according to the n, and you need to find out the Z transform, right? So let us see how we can find the Z transform and define its ROC. So over here, as you can see, it is 1 by 3 raised to n u of n. Why? Because it is the range which is n greater than 0. So over here for this 1 by 3 raised to n, it is for n greater than 0, that is for unit step signal, right? And it is n less than 0, that is on the negative side. So you can say that x of z that will be equals to a raised to n u of n. For that the formula is z upon z minus a, that is z upon z minus 1 by 3 over here, and this indicates the less than part. So for that it will be plus z upon z minus a only, that is z minus 0.5, but for this ROC will be changed because this is for less than 0 condition, right? So for that ROC is mod z greater than 1 by 3, and for this ROC will be mod z less than 0.5. So this is the basic difference between this ROCs, because according to the region given to you, right? So if we want to plot the ROC, it will be the entire Z plane for the greater than 1 by 3 and less than 0.5. So this will plot a ring. So if I want to plot the ROC, this is the real part of Z. This indicates the imaginary part of Z. This indicates the Z plane. Let us plot the circle having the radius z equals to 0.5, and another one is z equals to 1 by 3. Okay. So this indicates that it should be greater than 1 by 3. That means this part, and this indicates it should be less than 0.5. So that means it indicates that the ROC will be this ring. Okay. So this is the ROC of this given example. Alright. Now let's see one more example. So the next example is, find the Z transform if x of n that is equals to n into u of n. Okay, so this example can be solved using the property which is called as differentiation property, because over here the differentiation property states that n into u of n z transform is minus z d by dz of x of z. Okay, so we will write down first of all differentiation property. So according to the differentiation property, the z transform of n into u of n or n into x of n, over here we have taken x of n, that is u of n given to us, that will be equals to minus z d by dz of x of z. That means what we need to do is we need to find the z transform of the given x of n, that is over here u of n. Then we need to differentiate it with respect to z and multiply it with minus z. Okay, so according to the standard signals table, we have seen that the z transform of unit step signal is z upon z minus 1. So we are going to use that. So from this we can say that the z transform of given x of n, that is you can say x of z, that is equals to minus z d by dz of x of z, and over here x of z is what? Z upon z minus 1. So we will take z upon z minus 1. Alright. So using differentiation for the division rule, we can say over here the square of denominator z minus 1 square, denominator as it is, differentiation of the numerator, that is of z, that is 1, minus z as it is, differentiation of the denominator, that is 1. So that will be equals to minus z into, this will be z minus 1, this will be minus z, so z will be cancelled out. So over here it will be minus 1 upon z minus 1 square. This minus minus will be plus. So over here we have obtained the answer x of z, that is equals to z upon z minus 1 square. Right, so this is the answer of the z transform of n into u of n. It may happen that in your data they have given you n square into u of n, so that will be equals to n into u of n. So for that you need to do 2 times derivations. That means you will find the answer of this like this, and then again you will do the differentiation part for this n, and you will find the answer for that. Okay, so now using different properties and the basic standard formulas, you can solve any of the example for the z transform. These are the references. Thank you for listening.